Perfect. Well, hello, my name is Luke. I will share my screen now. Can you guys all see my screen?
Yeah.
Okay. You can all see my screen. You can all hear me.
Yes.
Sorry, I just stopped it. Okay, so I'm going to be talking about privacy and scaling for games. We'll go to the next slide and we'll have a little think about the overview and what we're talking about here. And because you guys are all building on top of StarkNet in Cairo or tentatively, perhaps not expressing the tools and languages, but it's more of a nomenclature with the state of the DSL. This game, this game that you're going to be building, is expressed through all of these zero knowledge constraints. So you don't have the kind of L1 complexity, you don't have the kind of L1 restrictions, and you get to scale it through ZK or in some case, validity rollups. You do that by adding in constraints. And I think when we think about where blockchains were and where they are and where they need to be, we see a kind of hop. StarkNet being the best example, because the first place you can impose these kind of different levels of constraints to be able to actually scale Ethereum, and now talk about serious use cases such as gaming. So today we're going to talk about the different leveraged points you get with using zero knowledge, as well as a couple of other technologies for both privacy and scaling. I'm not going to spend too much time talking about the specifics of how these games are scaled. I mean, we know you're taking a large piece of information, and rather than in a previous iteration of the web or in a fantastical Web 2 world, you would be sending all of this information tentatively through the air to some server where it would be beefed up and they keep this network alive. But we don't have that anymore because we're working on low latency and constrained devices and compute. So rather than send all of the information, we're just making proofs about the amount of information. This proof or this statement, or in many cases, these polynomials, these algebraic representations, they're really, really small. So that kind of advantage that StarkNet's taking at the moment is the ability to do something over, I'd say over here, but you can't see me, in your office area, in your bedroom, something on your machine. You make a statement that you've done that and you send it yourself, and through cryptographic primitives, it's checked on different points, or it's checked through some hashing commitments with Starks, and then if it's correct and it can't be falsified, then in fact the computation has been done. A lot of these proving systems, I don't know how deep you are and you have any questions throughout this, just take a stab, just jump out, and I will stop. I'll post them in the chat and I can stop incrementally. But these proving systems started not really with the scalability. It was I think a combination of Avi from Starkware, if I'm saying his name correctly, a little bit Vitalik and Barry Whitehat, who came up with the scaling through rollups for computation. But initially, this conversion of, well, we won't say conversion information, but statement about information, the really small proof. It's not only really small, but it's also only checkable in one direction. So it's private. So basically, I'm saying this because I won't go into the definition of zero knowledge proofs because everybody's heard it a million times in this statement. I want to talk a bit more about the implications, but it's the ability to check this information and not reveal any information other than that statement. So we'll be talking about past privacy and what it looks like, because some of the teams that I'm mentoring are building a private style game, and I think helping people understand the actual value of privacy in the previous world and the world we have today, in the current state of Web3, and also design for where we need to be going, is very, very important. And then we'll be talking about these scalable blockchains, and then how to build privacy and scalability, and then the value we really get from composing this high throughput and sovereign world. So what I want to think about first when we think about building and what we're looking at, not just for today, but for really for years to come for builders, is kind of failures of our predecessors. Sounds pretty intense, but you'll get me. So if we look a little at the history of internet privacy, we'll see on the timeline along the bottom that internet was, through the government, invented sort of 1960. I think if you speak to most people outside of the tech world, they seem to think the internet was invented sometime just in the 90s, because that's when it slipped into their lives. But as you can see, it was invented long before that and in use. And it wasn't until, if you look on the far right of the screen, 1995, that this SSL, which is a secure socket layering, was invented. So what it allowed you to do is do financial transactions over networks. So basically, before that, all the internet, all the information going over the networks was completely public. So you couldn't have financial transactions, financial applications. It's notably and ironically the exact same year that X.com, which sort of became PayPal, was invented. So as much as Mr. Musk may want you to think that he had some kind of new groundbreaking idea that that brought about the ability to financially transact, it wasn't him. It was this gap here. It was the people who brought on SSL, this little padlock you see in the top left of your screen. But what does that actually mean? That means for 35 years, we did not have privacy in the internet. So not only could we not do certain applications, not only could we not perform financial applications, things with sensitive information before we had TLS handshakes, the addition of this information in this 35-year span is literally hundreds of thousands of lines of unauditable, pretty exploitable, and some people would even argue designed to be exploited code systems, TLS handshakes. And the blockchain world we're building today is looking to make improvements in all different areas. And this is one fundamental area we must take into account, because we're not only changing things of the predecessors, but we don't want to be retroactively adding work on top of old systems that makes them broken, and we kind of build privacy for how it's going to look going forwards. And I think for that, there's a sentiment in the rest of society, just how we don't know the importance of privacy because we perceive it differently. It's almost like we should find far more synonyms: privacy, sovereignty, ownership, consent. I think these are really important when thinking about what it's actually worth, and then later on we'll go into what they bring to actual games, the actual fun benefits. So the top half, the kind of top left and the top right, the Web3 applications at the bottom are sort of previous iterations or previous or existing parts of society. So I'll start on the bottom. It may not seem that it's directly one-to-one related with privacy or performing private computation or the necessity to have private and sovereign networks, but all of the data is being taken there by Cambridge. You'll see having some censorship, not having DLTs, not having a single portfolio, not having accountability allows for censorship on referendums. But my favorite part about this, about talking about privacy and expressing it in the blockchain world, is it isn't actually transactional privacy that I have to talk about. It's the two at the top. It's the DeFi. It's having this other vehicle which allows people to understand the greater values of this thing that isn't just private, public, 1 or 0. It's the same as saying, well, going up to someone on the street who says they don't have, any issue, nothing to hide, saying, okay, well, unlock your phone and go through it with me. It's all of these behaviors that simply aren't enabled if we don't have privacy. So there's so many things that people think they can do, but by the definition of a basically public, tentatively ledger, there's lots of behaviors that you can't do, normal real world behaviors. But within blockchain, the moment it stands at realizing that there's MEV from being able to snipe, there's DeFi without privacy from being able to see how people's wallets go through, and not being able to move to a world where we can have perhaps payroll and people working and streaming the blockchain so you don't see incomes. But this demand doesn't just come from what I say, and people might not think they have it, but very recently, I saw that bottom right picture. It's on billboards all over San Francisco. It's kind of ironic, but people are talking about it a lot. DuckDuckGo, Signal, Tor, maybe to a degree, Silk Road. These things, they're not accidents. They're like blockchain was in 2009. They are knee-jerk responses to failures of privacy in the previous world and our ability to use technology to change it. And one of those that comes in is going to be how it affects computation, how it affects gaming computation, how it allows people within games to take sovereignty over their own in-game assets as that industry grows. So what are we talking about specifically in this context when we mean privacy in a blockchain setting? Just to give it a smaller definition without going into the sort of the IOP parts, it's the bottom two. So it's the anonymity and confidentiality that make up the top one. So in a basic sort of Etherscan transaction, you have address to address and amount. The confidentiality is the shielding of this amount or the shielding of some transaction, which can be necessary for some in-game economics or necessary to hide the state of where people are on a blockchain. And the anonymity is to hide the addresses or the two people the transaction go between, or the state there. So the privacy here is the combination of the two of those. So that's sort of the definition we're thinking about in the blockchain setting. And why is this important? Well, as I said before, blockchains, yeah, they're public ledgers. They're pseudonymous by default. So people seem to think that because it's a 0x or an E1 and an EB and some alphanumeric code that describes an identity online, that it's hidden. But it's not. Not only can things like batch attestations be done. So when you start signing certificates with these TLS I spoke before, and you go online, even when you do it through blockchains, you're still attesting to being somewhere. It may be a signature. It may not look like you, but really, really fancy and fascinating for sure. Machine learning models, as you'll have read about, can make batches of these data in the hundreds of thousands and start making, attestations about people in between them, start using crazy ones for it. But for me, the future of blockchain, making it private, making it scalable, whether it be through a continuation of another ZK rollup or validity rollup, whatever the specifics people are arguing about today, is just understanding the behavior that is permitted. And we have at the bottom here, DeFi. Simply in the way we have the world today, the way the state of the should make a distinction here. The Web3 world, the blockchain world that we're thinking about. Lots of these use cases are, one, not really possible without levels of privacy because of the behaviors they enable, and I'll go through them. And two, they're not really doable if they're not scalable. They're not feasible in the long term. So out of these, the reason I like gaming the most, and the reason I've highlighted it, is it's the only one that really isn't possible in the large scale, like the most baseline case, without both privacy and scalability. And of course, it ties into all of the zero knowledge and all of these roll-ups. I've highlighted as important, but I'll go through them all. So you start with something like DeFi. The failures or the examples that I gave before is two people transacting, one person's address gets doxed, that person's entire accounts are gone. People very openly and willingly posting online their accounts. There's never any payroll into theirs. You can know people's jobs, but people want ownership and sovereignty, not to have the whole world know their salary. And I'll skip and I'll go to gaming last. So I'll go to voting, just here. Voting the way it's done, and also in-game voting is very regularly a public activity, which is fine in some cases, usually a small number of cases in the world. But there's a reason that democratic voting is done in private, because the privacy here is sovereignty. It's sovereignty of your own mind. Sounds a little strong, but it's the realization that when you're making a decision, and that the decision for a democratically elected government, it should be as uninfluenced by anything other than objective pieces of information, but as not influenced at all by the game theoretic scenarios of open voting proposals in DAOs. People will go onto these forums, and the DAO and the governance itself is arguably a little fragmented at the moment. But people will go onto these forums, and you'll see that some whale or some DNS, some .eth guy has 60% of whatever votes in some pool, and he's voting towards something. Or let's pick an amount below 50, 10%, and you go, what's the point? Or some VC, some Polychain, some Paradigm, some A16Z. They've already voted for that. You'll get tail chasing on one side, or you'll go, oh, I don't see the point anymore. And that breaks down systems very, very quickly. Supply chains, as we see a huge failing in the world right now. Just a small nudge of a 6-day trap in the Suez Canal a couple of months ago with the Evergreen is still leading to huge issues. If anyone's like me was trying to build their own gaming PC, and they're doing it with a Ryzen, you'll have also waited 7 months for some of these things. For digital identities, you're not going to have off-chain credentials verified on-chain, which is going to be an important part of the private gaming ecosystem for sure, without having some kind of way to verify information at scale. And infrastructure, the way we see it now, computational overhead, composable computation. So things like oracles, trustless oracles coming to Starknet. These things don't work if we can't make some proof or statement about having the information and sending a much smaller representation rather than all of the information itself. And the last one, and the most important, the highlighted one, is gaming. So I think what we're talking about gaming, in the most base cases, we'll take gaming in the normal world. We'll take gaming the way it's done and in the most extreme examples here. So not mobile gaming, not a game of board games, but where we ultimately want to be able to either verify information or run on-chain games. Is the case of, your PS5, GTA, or your Xbox or your PC gaming. Computational overhead at the moment from different devices in blockchains is really, really far away from being scaled to the amount. And the case that is required for gaming, the case in point here could be running on Ethereum versus running on Starknet. The ability to define logic through this zero knowledge DSL, through this Cairo, that can express constraints about this large piece of information, and just make a statement about that information, is the first serious step to running some kind of not only individual teams and ease of use, but scalable game which can be working and interacting with a blockchain. And for privacy, I'm going to take the most extreme example again. Let's say in some L1, you're able to check state. You can go into Etherscan, you can check transactions. Sorry, 1 second. Sorry, I tried to mute and there were it didn't work. Is let's say you can go to some Etherscan, or you can go to some Starknet, or you can look at some block explorer and know all of the inner workings. By principle, if you have on-chain activity, all of the places, all of the states, all of the players in that game. So we're thinking like 2 players on Fortnite, or 2 players on some other monolithic game that dominates the industry. You can, in principle, snipe the block explorer. You can, in principle, constantly and consistently see where the other person is and basically be able to find them. You need off-chain abstraction, or you need verifiable privacy for on-chain gaming. Are there any questions so far? We're coming near the end. No? Okay. Well, I've left a little Q&A for the end, so we can talk about the implications of this. What are you thinking about for achieving private computation? Well, there are zero knowledge proofs. So this ability to prove you acted honestly without revealing information. There's commitments and encryption. You could even, in some case, run a game where you do a commit and reveal to a Merkle tree. So that would be easy for easier for card games, and just keep the the root on chain, which is, I think, a reasonable step for building something in Cairo. You can have stealth addresses and shielded pools like Monero and Zcash, and you can take network level privacy, which is much more to do with the interaction between our blockchains and the underlying kind of L0, the actual infrastructure of the internet itself. I think as far as this hackathon is going to be, doing this with zero knowledge proofs is going to be more difficult because the time it's going to take to encode them. But making some commitments in encryption to have certain behaviors, they'll be very cheap, very easy to implement, and allow you to have a decent level of privacy, just without, I guess, too much expressivity. And what does it look like for the value proposition of a private game? Well, the first two kind of work together. The playing by the rules without showing your cards, and the revealing any information. Actually, honestly, without revealing any additional information. So I like the constraints that we're able to set in with games here. We're able to take games and take almost anti-cheating, unless in some games where cheating's enabled or encouraged because it's part of the game. But the ability to predefine a set of rules and know that everybody's playing by them honestly is not only word for word definition applicable to games, but it's also very, very useful for knowing that we have some particular behaviors and no one's perverting them. We have this real world behavior in a decentralized setting. So beyond gaming, that's the voting that we spoke about before, the ability to have democratic voting, the ability to be able to actually hide your payroll, the ability to but know that you work for some place. And then we can also, because it's the zero knowledge, as I said at the start, sort of birth the two ideas, the ability to compress information, or better say, make statements about information, as well as actually show some information without revealing information, is alleviated both these kind of scaling drawbacks and privacy drawbacks. Then we can create privacy tooling, but I won't. I'll go into that in questions because we're running a little bit lower on time. And what does this look like as a proposition of a scalable game? Well, you can have verifying of large off-chain computation on-chain, depending on the structure in which you want to create your game. Of course, with the technology that's available at the time, running on-chain high-throughput games is going to be difficult for a fair while. Then you can have on-chain collectibles. So like Counter-Strike, without having some intermediaries, you can have some ownership, some NFTs on the game. And with a permissionless and decentralized system for on-chain gaming, if we're scaling games to large permissionless systems, you don't have the single point of failure. When I was a little bit younger, I really liked playing Halo, and now I'm sad because I can't play Halo anymore. I can't drive around in wraiths because they shut the servers down. In a decentralized environment, we won't have that anymore. I think it would be honestly very enjoyable from a retroactive standpoint if we could go back and play a lot of sort of, well, not beyond my age, but sort of our parents' age, people from the 60s and how to play. But we enjoyed the Atari games, and right now the technology we have for rejuvenating things is mostly just rendering old movies, rendering old images. But if we could have a point where you could always go back and collect the instantiation of some gaming logic, collect some contract and rerun it, I think that would be fantastic. And of course, this is organized and retrievable, and one day will work well. We also have this, if you have a fully in-game economy, a full circular economy, you can have better remuneration for in-game earnings. And I think that's going to be one of the larger places. The creator economy, the gamer economy are growing, are arguably still rather large, and I think take what everybody could argue very, very ostensible benefits from blockchains, and tying into things like the in-game property ownership of the metaverse and moving towards creating a metaverse world where it's not really, again, I'm looking for synonyms to privacy, but also looking for synonyms to games, but knowing that you can go and have some activity, some economic choices, some interactions with others being made in a game style way. I mean, as I said before, game theory, it's just the layout of the interactions between individuals. And when you have these things with the metaverse, when you have property ownership, you'll only really be having these when you can express through next iterations of tooling. And what is the challenges of these ZK games? Well, we have technical efficiency. So the state of current zero knowledge doesn't apply too much to Starknet. I guess just more the developer experience and the user integrations. But they're still compounding along the rate. The costs of doing as such, roll-ups are only lowering the cost at the moment. We have this developer experience, although Cairo is maybe the leader doing well. There's still some tooling to go, and feel free to nab me afterwards, and we can look at doing that. I've built a little bit, so we can build some together if you'd like. But not having the ability to basically make these DSLs, these individually, these DSLs made up of, in many cases, complex constraints, or even, defining this air and compiling it to very specific strengths. So you would do it technically on behalf of Cairo is rather complex, and there's no need for everybody. So we're looking for the correct levels of abstraction. The user experience on and off the blockchain, I think we're all quite au fait with, is I don't know, less than desirable, for sure. Less than desirable in how we can interact with blockchains, with the high levels of friction, and these things are sort of increasing as we add more layers of complexity when programming games. And the last two are the social perceptions. People don't care. I tried to very briefly at the start talk about what privacy actually is in terms of zero knowledge, what it actually enables. Not just, oh, there's an Ethereum transaction here for $1, or I'll put a wrapper on it for $1.10 and it's private. People see that as all that privacy encompasses. But consent over your information, composable and configurable privacy, these things are very, very, very different. And I think not just desired, not just wishful thinking, but they're just this behaviors which are just not possible if you can't have it privately. And then the kind of regulatory part, but this was more me just sticking in basically one sentence, because it's the one VC angle that people think about with respect to sort of levels of privacy on chain. So how to sort of summarize what this is looking at? Obstacles to it seems to have been cut off. It says to a fully scalable and private world. Maybe it's outside this box, outside this oval, sorry. So this is supposed to say obstacles to a fully scalable and private world. Well, the first is scaling blockchains is these complex cryptographic techniques. It takes some time to learn them. Different games have different privacy edge cases, so they'll need to be particularly composable. There's no human resources to go and build these. I guess a lot of the problems I've stated are pretty abstract from what Starknet's achieved, and then coding all of these is difficult anyway. We have a UX issue where I think a lot of the teams now are going to have to be very pensive about where they compose and what pieces they put on chain and what pieces they keep off chain. People don't want extra clicks. If you're having some in-game economy, that means you're porting information to and from off-chain environments that it can be computed and made on-chain. It's dealing with that abstraction with an immutable ledger. And then, as I said before, the social sentiment that comes with privacy. So users don't understand the value of privacy. There's minimal awareness to the dangers of privacy misuse, and people don't know the kind of behaviors that it enables. That is all. Hope I got through that in a good time. If you guys have any questions, you can do it like this, or I can turn my camera on and we can chat.
Hi, thank you. Thank you, Victor. Yeah, go ahead.
Hey, Luke, I have a question.
Yeah.
I was just wondering if there are any open source applications which use zero knowledge, and then they solve some scenarios on Starknet.
Just to clarify the specifics of the question, you're talking zero knowledge applications that solve things on Starknet? Well,
For example, if there's a privacy preserving app for any scenario, like for NFT trading or any other scenario, or any app in general which uses zero knowledge on Starknet
zero knowledge on
and is open.
an open source? No, not that I know of. Ellie, if I'm unknown to some of them, please do correct me, but I think not. I know of a few around the whole blockchain ecosystem. And I mean, Starknet by definition uses this zero knowledge. I assume you're talking about adding a layer of zero knowledge for privacy onto Starknet, which then has the zero knowledge for scalability.
So my intention is to understand how Starks can be implemented.
Well, for the reason I put in the commitments and encryption, the stealth addresses and the shielded pools is because the top one, and maybe I forgot to mention this, sorry if it's at the tongue, it's going to be basically impossible in this week to implement any form of zero knowledge primitives. You'll have to just use privacy like commitments. I gave the example of the Merkle tree. You could probably build a logic like dark forest. So that's, have you heard of dark forest?
Yeah, so I have seen dark forest implementation using ZK snarks, but outside of this hackathon as well, just for my knowledge, I was curious to know about Starks and how they can be integrated.
Okay, yeah. Well, you will just have to have basically in this case a ZK role, an extra layer. The only one of open source zero knowledge Stark based privacy preserving games I know is Battleship on Risk Zero's Risk V or Risk 5 or Risk V implementation. If you've heard of that, so something like that could work. But the difference is you're not just, it's the when you're doing it as a roll up that you're taking these transactions and you're making some proof about them, but the inputs, the witnesses that go actually in are not private. So you just have to have like exactly what they have now, but on Starknet, but a layer of this inputs of witnesses for these circuits as private inputs.
Okay, thanks so much, Luke.
I'll write that down. I'll send the link actually for the.
Awesome.
Are there any more questions about anything, whether it's like from the slight investment size or where the value is, or what games will have to look like to enable behaviors that arguably take advantage, well, take for granted? Okay. I just sent the Risk Zero one, which is an example of Battleship written inside of their Stark machine. This exact example you could also use with the Merkle tree in the state, which could be quicker. But it's a perfect case of where, of course, not all games could you play with this commit reveal. You would need some, instead of like this discrete log based structure, you need some maybe like stateless machine, but obviously not for this week. Well, if there are no more questions from anyone, unless Ellie knew, by the way, of a privacy preserving game built on Starknet that I missed.
Can you specify a bit?
Yeah, a game which uses zero knowledge to make private witness inputs that's built on Starknet. I think the answer is no.
Yeah, I can tell you for sure about this.
There's also
Yeah.
so few in the world that I think I probably would have come across it. But maybe you can build it. If you reach out to me, we can have a little chat about it. We can look at the facility risk. I have a couple of other examples, and we can look at codified board games, which may be a the easier ones to go for. Maybe here's a cool one with an expressivity. Is it Wordle? Wordle on chain, that would require some kind of privacy preserving primitive. Oh, okay.
Yeah.
If there's nothing else, you don't want any questions from me, feel free to. I'll put my email here. Yeah, I'm in all the chats. So just ping me in the Discord, or you get me on Telegram, or if you have any questions about any of this, or you want to chat about it, feel free to do so and talk about one of the implications of making games scalable.
Well, thank you very much.
Perfect. Thanks everybody for listening. I hope you had as much fun as I did. I'll look forward to seeing all of your submissions.